The next definition is unit step function or Heaviside unit function. Now just a definition. If we have this type of function, then for this function also we can apply the Laplace transform. Here I am explaining just a definition, and one more definition is there, second shifting theorem or second translation. Both things I will explain you here. After that I will one or two problems based on these two topics. Now the unit step function is defined as h of t minus a or u of t minus a. This is capital H of t minus a or u of t minus a, that equal to, they have given for these two functions, for this function they have given two values. 0, the value of this function is 0. When it is 0, if t is less than a, and 1, the value of this function is 1 when t is greater than a. Now this function is denoted by h of t minus a or u of t minus a. For this function they have given two values, 0 and 1. 0 is if t is less than a and 1 is if t is greater than a, like that. Then if you want to draw a graph u of t minus a or h of t minus a, then this is t with respect to t only. T is less than a and t is greater than a, means horizontal line I will consider as t axis, t. Then if it is exactly a, the value is 0. I am not marking here. This is the value t of a is, then u of t minus a is 0, means here this is the starting point. The next, if t is more than a, if t is more than a means this is this one, then what is that value? Exactly 1, means t is more than a, like this. Dark line is available here, observe this one. This is the function. Now if you have this type of function, then how to apply the Laplace transform for this function I will explain in the problem. Now this unit step function is important for the second shifting theorem. Now the same thing, second translation or second shifting theorem, just a statement only. Laplace transform of if Laplace transform of f of t equal to f bar of s. This is known quantity. Laplace transform of f of t means f bar of s, means Laplace transform of unknown function f of t means in given function f of t, the answer is in terms of s. This is known. Like that we can calculate f bar of s. And g of t is, they have given two functions, f of t minus a when t is greater than a and 0 t is less than a. Then Laplace transform of g of t e power minus as into f bar of s. This is the formula. This is first type. Once again, Laplace transform of f of t equal to f bar of s, known quantity, and g of t is, if it is in this form, means f of t minus a when t is greater than a, 0 when t is less than a, when g of t has two functions, has two values, two values, then Laplace transform of this type of function g of t is, the answer is e power minus as into f bar of s. Next, another form of the second shifting theorem. Now the statement, if Laplace transform of f of t equal to f bar of s and a is greater than 0 everywhere, no negative number, then Laplace transform of f of t minus a into h of t minus a, means if the function is like this, f of t minus a into h of t minus a equals to e power minus as into f bar of s. The same thing again, h of t is, again here h of t is 1 when t is greater than 0, h of t value is 0 when t is less than 0, h of t is called Heaviside unit step function, because previously h of t minus I have taken, here a value is 0, t minus 0 means a value is 0. This is the statement of another form of second shifting theorem. Like this, by using these two second shifting theorem, first type, and another form, by using these two concepts, I will explain the problems. Now when should I apply the first form and when should I apply the second form? Easily you can identify the problems very easily. Now let me explain the problem. First problem, I have taken two problems in this. Find the Laplace transform of g of t where g of t equal to cos of t minus pi by 3 if t is greater than pi by 3. 0 if t is less than pi by 3. Another one, g of t equal to cos of t minus 2 pi by 3 if t is greater than 2 pi by 3. Another value of g of t function. This is the second question. If t is less than 2 pi by 3. I have taken two problems here. Observe the problems very carefully. Now first form, Laplace, recall the statement once again. Laplace transform of f of t equal to f bar of s, and g of t is f of t minus a. F of t minus a. Now observe this one, g of t equal to cos of t minus pi by 3. T minus a value is pi by 3. The answer is for this one, what is that? E power minus as into f bar of s. Actually, according to second shifting theorem. Here we have two types of second shifting theorems. One is second shifting theorem and another form of second shifting theorem. I am talking about second shifting theorem. Now first solution for the first problem, f of t is cos t, because f of t minus a means f of t is cos t, according to that one. Now here g of t is f of t minus a equal to cos of t minus a, suppose. Then f of t is how much here? F of t is cos t, like that. Now f of t is cos t, then Laplace transform of f of t equal to Laplace transform of cos t is nothing but s by s square plus 1, f bar of s. Now Laplace g of t, they have given this function, g of t equal to f of t minus pi by 3 equal to cos of t minus pi by 3 when t is greater than pi by 3, 0 value, then t is less than pi by 3. Applying second shifting theorem, Laplace transform of g of t equal to, the answer is pi value, a value is pi by 3, am I right? Pi by 3. Then e power minus pi s by 3 into f bar of s is s square, s by s square plus 1, s into e power minus pi s by 3 s square plus 1. This is the answer according to second shifting theorem. The same thing directly I am writing here. Laplace transform of g of t equal to, for the second one, here a value is 2 pi by 3, am I right? Then e power minus 2 pi s by 3 into s by s square plus 1. Because again the function f of t is nothing but cos t, that's why I am using s by s square plus 1 into e power minus 2 pi s by 3. This is the problem based on second shifting theorem. Now let me take the another problem. Find the Laplace transform of, first question, t minus 2 whole cube into u into t minus 2. Second question is e power minus 3t into u of t minus 2. Here I am using, actually this is product of two functions. The previously g of t they have given. In another form of second shifting theorem, Laplace transform of f of t minus a and h of t minus a, two product of two functions. When do you have product of two functions like this, t minus 2 and t minus 2, both functions are available. Observe this one, t minus 2, t minus 2. Then another form of second shifting theorem you have to write. Then both should be t minus 2, t minus 2. Comparing the given function with f of t minus a into u of t minus a, we have a equal to 2 and f of t equal to t cube. First calculate Laplace transform, because the answer is everywhere e power minus as into f bar of s. F bar of s is what? Laplace transform of f of t. That's why I am calculating Laplace transform of f of t equal to Laplace transform of t cube equal to 3 factorial by s power 4, that equal to 6 by s power 4. This is nothing but f bar of s. Now applying second shifting theorem, Laplace transform of t minus 2 whole cube into u of t minus 2 equal to e power minus 2s into f bar of s is 6 by s power 4. 6 into e power minus 2s by s power 4. This is the answer. Now second bit, Laplace transform of e power minus 3t into u of t minus 2. Then e power minus 3t means the t instead of t we need t minus 2. Now observe the another form of the second shifting theorem, Laplace transform of f of t minus a into h of t minus a. The both functions in terms of t minus a, t minus a. H of t minus a into u of t minus a. Here the second function is u of t minus 2. The first function is e power minus 3t. But we need e power minus 3t minus 2. Wherever t is there, there I need t minus 2. Then only we can apply the another form of the second shifting theorem, because both should be in terms of h of t minus a, f of t minus a. I'm underlining this part. Please observe this. Then directly I am taking Laplace transform of e power minus 3. Instead of t I am writing here directly t minus 2. Again, then e power minus 3t is available, but extra term is e power minus 3 into minus 2 is e power plus 6. Then to balance that one, I am multiplying with e power minus 6. Then if we are multiplying with e power minus 6, again we are getting the e power minus 3t. Means observe this one, e power minus 6 is constant into u of t minus 2. E power minus 6 is constant, that's why I am writing outside of the Laplace transform. E power minus 6 into Laplace transform of e power minus 3 into t minus 2 u into t minus 2. Now we can apply the another form of the second shifting theorem. Means if it is in the form, if it is not available to compare with the another form of the second shifting theorem, then we will do some modification. According to that modification, I got in the form of another form of the second shifting theorem. Now we can apply very easily. What is f of t according to this one? T minus 2, t minus 2. Instead of t minus 2, you should understand that is t. F of t is e power minus 3t. Then f bar of s equal to, what is that? 1 by s plus 3. Because Laplace transform of f of t is nothing but e power minus 3t. That's why I am writing here directly f bar of s equal to 1 by s plus 3. Laplace transform of e power minus 3t value is 1 by s plus 3. Now, and using second shifting theorem, we have Laplace transform of e power minus 3t into u of t minus 2. Means this both are same. That's why I am writing directly question here. E power minus 6 into, what is that? E power minus 2s into e power e power minus 2s into 1 by s plus 3. Because why should I write e power minus 2s? E power minus as into f bar of s is the answer. E power minus as into f bar of s. That's why e power, on simplification, e power minus 2 into s plus 3 by s plus 3.